Welcome to EE World. I'm Senior Technical Editor Martin Rowe, and we are at the International Microwave Symposium in San Diego, California. This is the Analog Devices booth, and yesterday Analog Devices made a major announcement for a product family called Apollo, which I'm going to let Brad explain because it is such a major announcement that I'm not ready to explain it yet. So Brad Hall, why don't you tell us what this is and tell us what you've got in here.
Sure, yeah. So this is a new digitizer IC subsystem.
If we could get the camera down over here so we can see it. There we go.
Yeah, this is a new digitizer IC subsystem that ADI has just announced called our Apollo MXFE device. It has 4 ADCs and 4 DACs in a single IC. The ADCs can sample up to 20 gigasample per second, and the DACs up to 28, with an analog bandwidth that extends up to 18 gigahertz.
18 gigahertz.
So this is enabling, new direct sampling architectures and also architectural simplification in the front end. So in the RF components, the mixers, the number of mixing stages, and that's kind of also what we're showing here at this demo is how to take that 18 gigahertz Apollo and extend that up to 55 gigahertz with a fairly simplified and low size RF front end. So this demo is kind of showing that whole solution.
So by being able to digitize up to 20 gigasamples per second, that means you can digitize RF directly. So that's where all the mixers and all the filters and so on aren't needed,
Right.
Because you can do a direct sampling of the RF signal.
That's right.
Okay, and from what I understand, it's more than just an ADC. That it's got some processing power. It's
That's
got some
right.
DSP in there. And
Yeah.
from what I heard, that it kind of puts Analog Devices back in the DSP business.
Sure, yeah. We have, behind each ADC is a full digital subsystem as well. So it has, extensive options for decimation, interpolation, frequency tuning. There's options for sniffing the spectrum. So we have an FFT sniffer that allows you to essentially view the whole spectrum. And, programmable FIR filters, and a lot of what we're doing by implementing this in the device, in the IC, is that helps offload processing that's needed in the FPGA, resulting in an overall more efficient system, like an ADC plus FPGA system that's lower cost, lower power, and higher performance.
So the DSP eliminates the FPGA and they can be power hungry.
Yeah, not eliminate, but it reduces the amount of processing that you need in the FPGA. Okay. So you can choose a smaller FPGA, for example, that pairs up with the Apollo device.
And there's quite a bit of software that's got to go along with this that ADI is developing or has developed. Can you tell us a little bit about the software support?
Sure. Yeah, we provide an API to kind of ease the implementation. So there's many thousands of registers in the device. It's extremely complicated, but we provide an API that allows the user to kind of easily configure the device just through commands and that kind of thing.
So this is the device right here, I'm assuming.
Yeah. This is the Apollo device.
Okay. And now, is this just a demo board, or is this is this a demo board for the show, or is this a demo board that will be available to users?
Yeah. So what you're looking at is actually our eval board for the device. So this is the one of the revisions. This is basically what a customer would get if they were, trying to get the part to evaluate it in their lab. We provide this board as well as this board. This is our ADS-10 board, and those two work together. So we send, the ADC data over to the FPGA, and then we compute FFTs and that's where our evaluation environment operates as well. So this is the customer-facing evaluation system.
And did you say how many channels, how many analog inputs, analog outputs can this support?
Yeah, 4 ADCs,
Four
and 4
ADCs.
DACs
Okay.
on the device. Yep.
Okay. All right, very good. Thank you very much.
Sure.